Hi class. So this is the second part of substitution. Previously, I went over some example with you using U substitution. For this example, remember I told you about picking the complex expression and call it U. So when you look at this problem, you might think, okay, U should be 1 plus x squared, right? U is 1 plus x squared. The problem is when you get to du, is 2x dx. But we have not just 2x, we have x to the 5th power. So we should break it. We should take x to the 5th power and break it into x to the 4th and x. The reason I want to do this is because right here, I have just x and x here. Now, you know that for the constant, we can just divide it and then we get rid of it, right? But what we have is the variables. So we're gonna have to do more substitution on that. Now, as you can see, so I'm just gonna go back here, u equals to 1 plus x squared. So you can see that x squared is in fact u minus 1, right? What we have is x to the 4th. So if x squared is u minus 1, x to the 4th is going to be u minus 1 squared. Okay? So now I think we have everything. We have x to the 4th, we have x dx, and that too, you can just take it out, right? Okay, so let's proceed the problem. So I have the integral square root of x plus, 1 plus x squared. And instead of writing x to the 5th power, we're going to write x to the 4th times x dx to match them up. Now, we use substitution. Instead of square root of 1 plus x squared, we now have square root of u. Instead of x to the 4th, we now have u minus 1 squared. And then instead of x dx, we have 1/2 du. Okay, don't forget I divide by 2 here, I divide by 2 here. That's why. Okay, so now we can simplify. So you might want to FOIL, and then we have to distribute the u over, the square root of u over. So I'm just gonna first take the 1/2 out. And in here, u minus 1 is gonna give you u squared minus 2u plus 1. Okay. All right. And then from there, I can distribute the square root of u. So if I distribute, I'm going to get u 5 to the 5/2 minus 2u to the 3/2 plus u to the 1/2. Notice that I changed square root to 1/2, so that's how I can just easily distribute. Okay, from here, we can take the antiderivative. So I still have 1/2 here, and then we have 2/7 u 7/2. When you divide by 7/2, you multiply by 2/7. So you should all know that we multiply by the reciprocal. So this one right here, I have that 2, and then I have u to the 5/2 divided by 5/2. So that's going to be 2/5 plus u to the 3/2 divided by 3/2. So that's going to be 2/3 plus c. And then we're going to have to go back and put everything in. Okay. Anyway, make sure you distribute the 1/2 as well. So distribute, distribute, distribute. So what I have is gonna be, let me just distribute first. So 7u to the 7/2 minus, so we have 2, cancel out with 2, so minus 2/5 u to the 5/2. And then I distribute one more time, I'm gonna get 1/3. 1/3 u to the 3/2 plus c. Okay, so now I'm gonna go back and plug it back in. Instead of u, we go back and do x. I totally forgot what what u is. 1 plus x squared. Okay, so 1 plus x squared, 7/2 minus 2/5. 1 plus x squared, 5/2 plus 1/3. 1 plus x squared, 3/2 plus c. And we're done. Okay. All right. Moving on. Okay. So for this example, I really don't know what to use for u substitution, because tangent is just tangent. So you might want to change it to sine of x over cosine of x dx. All right. So in this, now you can let u be cosine of x. Now, if u be cosine of x, du is going to be negative sine of x dx. So we have that negative. You have to take that negative out. So I'm going to take it out. Negative. Okay. And then, so this time we have negative 1 over u. Okay, because u is cosine of x, it's on the bottom. 1 over u du. Now, we all know how to take the antiderivative of that one. So it's going to be negative ln absolute values of u plus c. Okay. Now I can go back and plug it in for u. And u is cosine plus c. Okay. So now we know the antiderivative of tangent of x. And then so if you want to rewrite and you want to get rid of that negative, hopefully you still remember. Here, I can go ahead and get rid of the negative. So think of this as negative 1 ln of cosine of x plus c. So if it's the number in front, you can move it to the power. So this one is going to give you ln of cosine of x to the negative 1 plus c. So as you can see, if it's cosine of x to the negative 1, so is ln of 1 over cosine of x. Let's see. So that's why now we can say that tangent tangent of x, if you take the antiderivative, the integral of tangent of dx is going to be ln ln of the absolute values of secant. Okay. All right, moving on. So those are the indefinite. Now let's go to the definite integrals. Okay, so for the definite integral, you also have a substitution rule, but notice that you go from a to b, and then when you plug in the function for u equals to g of x, you're going to have to change it to g of a and g of b right there. Okay, so pretty much we have to evaluate all the way before we plug it back in. Okay, so right here we have to evaluate 0 to 6, right? We did this problem in part 1, but anyway, I can just go ahead and remind you. So this one right here, for those of you who didn't know how to do it, you see we can just let u equals to 2x plus 1. And like I said, eventually you don't even have to use u. You look at the problem, you can tell. Because when you take the derivative, you ended up with just 2 dx. Okay, so we have dx there, we have 2 dx, so you have to get rid of that 2. We have to get rid of that 2. Okay, anyway, we have x equal to 0 and x equals to 4. You're going to have to use u and plug it in, right? So if x equal to 0, u is going to be 2 times 0 plus 1, so it's going to be 1. X equals 4 is going to give me 2 times 4 plus 1, so that's 9. So now, when you plug in the integral, instead of 0 to the 4th, we have 1, 9, 1/2, square root of u du. Okay, since we did this problem, I'm just gonna go ahead and make it quick. U to the 3/2, then I multiply by the reciprocal right there, and then we evaluate from 1 to 9. Okay. Okay, so cancel right here. I have 1/3. Then I have 9 to the 3/2 minus 1 to the 3/2 is just 1. Okay, and you can calculate it, and then you're gonna get 26 over 3. Yeah. All right, so that's how you do it when you have the limit, the upper and the lower limit. Okay, so for this problem, once again, we can tell that u is 3 minus 5x, right? So it's kind of obvious. Anyway, if u equals to 3 minus dx, du is going to be negative 5 dx. So I do want to get rid of that negative 5. Okay, now u equals to 3 minus 5x. So when x equals to 1, u is going to be what? 1, you plug in there, 3 minus 5 is going to be negative 2. When x equals to 2, u is going to be what? 3 minus 5 times 2. So it's going to be negative 7. Okay. And then we can just go ahead and plug it in. So I have, instead of 1 to 2, now we have negative 2 and negative 7. Oh, don't forget we have that negative 1/5. So So I can just put negative 1/5 here since I'm running out of room. Okay, -2, -7. And then I have the function right there. So it's gonna be du over u squared. Okay, now we're gonna take the antiderivative. So I have -1/5. So u squared on the bottom, you move it up, so it's u to the -2. So we add 1, so it's -1. So we ended up with -1 over u. And then we evaluate from -2 to -7. So it turned into positive 1 over 5u. 1 over 5u, -2, -7. Okay. So we have -1/5, and I have -1 over 7 minus -1 over 2. So when you calculate, you're going to get 1 over 14. Okay. All right. So as you can see, I don't even have to go back and plug it in for x because we already solved it for u. So we're just going to stick with u. Okay. Now, this one. So you see that if you let u to be ln x, what happened when you take the derivative? When you take the derivative, you get 1 over x dx, which is right there, the original problem. You see that? The original problem is ln x divided by x dx. So it's actually really nice. It's actually really nice. And we have x equals to 1 is gonna give you, I'm so sorry, the ringtone. X equals 1, and then u equals to ln x. So u is gonna be ln 1. So it's gonna be 0. X equals e. It's gonna give you u equals to ln e, which is 1. Oh, that's very nice. So now we have a new interval. So we have from 0 to 1. U du. So this is really sweet. So it's just u squared divided by 2, and then I go from 0 to 1. So that's 1/2. And there we have it. Okay. All right. So it works out really nicely. Now I want to quickly go over symmetry with you because it's really easy. So you can see right here. So if f is continuous on a -a to a positive a, and if f is even, and that's the definition of even right there, f of -x equals to f of x, then if you have to take the integral from -a to a, you can just, I'm sorry, this is a. You can just take from 0 to a, and then you double it, okay? For odd, they're gonna cancel out. So -a to positive a is going to be 0, so it's cancel out. It's really nice. So for number a right here, you can see I break it down for you, and number 8 and 9, we just break it down based on the symmetry. So let's take a look at number 10. So you see f of x equal to x to the 6th power plus 1 is even, because if you try to evaluate f of negative x, you're going to end up with f of x. So it's even. Therefore, if I want to integrate from -2 to 2, I'm just going to use part A right there. So all I have to do is go from 0 to 2, and I double it. Plus 1 dx, right? Yes, so that 2 right there is very important. So I just double it. Anyway, so you're going to get x to the 7 over 7 plus x. 0 to 2. And then, of course, I'm going to double it. Okay, so we ended up with 2 to the 7 over 7 plus 2. So if you use a calculator, you're going to get 284 over 7. And there we have it.